Start. And here we are. Recording kicks off. So look, we are living in incredible times. The speed at which things are changing right now is thrilling, right? We're seeing how generative AI is changing the way software is being built and is shipped. And that's exciting to me. I hope it's exciting to you too, especially at Google, where we are releasing state-of-the-art models and new software and features on a near daily basis. So just a week and a half ago, we launched Gemini 3 Pro. How many of you have used it, tried it out? A few, okay, great. That's exciting. We weren't satisfied with just launching a new state-of-the-art model. We actually wanted to do more. So the other thing that we launched was something called Google Anti-Gravity, which is our agentic development platform. This is going to keep popping up whilst people are joining. Please ignore it, and we'll keep going. So we launched Anti-Gravity, which is an agentic development environment. It's a new way at looking at how to build software. So if you haven't checked it out, please go and do so. It's really awesome. But we weren't satisfied with that either. 2 days later, we shipped Nano Banana Pro, which is a state-of-the-art image creation and editing model. It's phenomenal to see the kinds of art that you can make out of it, how realistic the images are. This particular model is fantastic at making sure that the generated text is spelt correctly, is very legible, matches in style, and is consistent. And it's just really, really been awesome to see all of the exciting use cases that developers are using around, use cases that people are building for with these models and these products. So thrilling times at the moment. Now, for many of us who are building and developing software using generative AI, it can feel a bit uncertain because the landscape might seem like it's constantly changing. It's something that we have to always adapt to. There's new models, there's new frameworks, there's new tools. And we're just constantly on the move there. So, like, although it's great to have options than ever before to build software with, we see that app developers and platform engineers are coming up with lots of questions. The kinds of questions that we may be asking ourselves as app developers is, how do I begin to handle the unpredictability of LLMs? What's an agent? What's an MCP server? Where do I run it? How do we keep up with all of this rapidly changing technology and still keep shipping features that our users love? That's app developers. Platform engineers are sitting there saying, how do they build a solid foundation on all of this innovation? They're asking questions like, how can we build a solid cloud foundation for our whole organization? How can we make the best use of accelerator hardware? How do we best utilize logging, monitoring, and tracing? How do we secure all of these new AI applications? And very important and sensitive to all of us is, how do we keep costs under control? These are the big questions. So today, I want to show you how we can start to answer these questions. First, we're going to be talking about how to build powerful AI agents. And just as importantly, we're going to talk about how to architect them so that they're durable and scalable. So let's start with that first question. What's an agent? Now, if you think about traditional software development, you would have an algorithm that you'd write. You take some input, you would have some if conditions, some loops, fairly deterministic, and it would go through that algorithm and give you an output. That's just how we've been doing software development for decades. Agents are different. With agents, we give them a goal. We give them the capabilities to go solve that particular goal, and then the agent goes and decides which capabilities to use when, and it tells you when it's ready, when it's solved that goal. Or it might tell you that, hey, I couldn't solve it. But you're no longer describing your application or writing code step by step. We're embracing a whole new paradigm here. So designing an agent starts with a system prompt that defines its focus. Now, this particular system prompt is from an agent that we built that was simulating a video game, where we had where we were telling the agent that you're an AI agent designed to help adventurers fight fearsome monsters. That was the goal that we gave it. But the prompt is just the beginning. The agent by itself won't be able to achieve its goals without a model and tools. So the agent needs a brain to be able to approach this. And that's where the model comes in. And just as crucially, it needs tools, because tools are what connect your agent to the outside world. They allow it to look up information in the database, to make API calls, or perform actions. And this is similar to how you do your job. When you have good tools that you can use, you can do your job easier. So by building specialized tools for your agents, you can empower your agent to be efficient for your use cases. So now that you know what an agent is and what it consists of, you've got to think about, well, how do we go about building an agent? Now, to help you build and deploy agents seamlessly on our platform, Google has built the Agent Development Kit, or ADK. I'll refer to it as ADK from now on. It's an open source framework for building and deploying agents. How many of you have heard of ADK? Okay, keep your hand up if you have used ADK. How many of you have an agent in production today? Okay, far fewer hands, but we've got a few, so that's encouraging. That's great. Now, I want to make sure that we bring everybody along. So ADK is a complete framework that helps you manage all the critical pieces of your agent. Things like your core agent logic, where you can easily create loop agents, parallel agents, and sequential agents with a single line of code. You can also define the tools that your agents can use easily. ADK comes with something called the MCP toolset, which allows you to easily connect to MCP servers and also enable authentication. If you're not sure what MCP is, don't worry, we're going to be covering that in a few slides. But ADK also makes it easy to implement things like memory, like orchestration, and even deployment. The point is, you don't have to build all of this from scratch. ADK provides these critical components that you need right out of the box. So you can build powerful and reliable agents, and you can build them faster. So let's dive a bit deeper into a basic agent that's built with ADK. Now, at its core, ADK connects your agent's logic to a powerful model, the brain, remember? Now, I'm sure you're not going to be surprised. My favorite model is Gemini. So I use Gemini on my agents. But actually, ADK is model agnostic. You can use any model from any provider with ADK. So with my favorite series of models, the Gemini family of models, you have a few options. You need to choose the right model for the job. You have the 2.5 Pro model, which is great at handling complex tasks. So if you have an agent that requires a lot of complex thinking, has to pull in data from multiple sources and make decisions on that data, the Pro model is a good fit. We also have the Flash model for speed on everyday tasks. And actually, my advice to you is, as you think about building agents, start with the Flash model, because the Flash model is incredibly capable. It's actually quite fast, and it's quite cost efficient too. But we can optimize even further, and we have a model called Flash Lite, which is super fast. Its latency is incredibly low, and it's great when you've got to handle tasks at scale or you have real cost sensitivities. Now, the interesting thing about choosing a model with your agents is you don't just have to choose a single model. Your agent will pick a model, or you'll need to provide your agent with a model, but you can have multiple agents, or you can have sub-agents. And each of those sub-agents, or the sort of multiple top-level agents, they can use different models. And when you think about model usage in your agents, there's three trade-offs that you should think about. The first one is just its capability. How smart is the model? What kind of complexity of tasks can this model solve? The second is latency. How quickly does it respond to you? If it's a very deep thinking model and it takes tens of seconds or minutes or even longer, that might be a bad user experience for the app that you're building. So the first one that you need to think about is capability. The second is latency. And the third is cost, right? You're going to be running these agents, doing lots of loops and lots of invocations. So these three trade-offs are what you should keep in mind when you build your agents, and that's when you should look at which model fits your specific use case. But I know what some of you are thinking. You're sitting here thinking, hold on, Google just announced Gemini 3. Why is he talking to me about Gemini 2.5? Are these slides out of date? No, they're not. The first thing I want to say is that Gemini 2.5 is generally available. That's why you see it says GA at the top, which means it is production ready today. And we have many businesses, even Google's own products, using Gemini 2.5 in production. A week and a half ago, we announced Gemini 3 Pro, which is currently in preview. I'm going to tell you more about the model in the next slide, but that bit that it's in preview is really important because at this stage, we want you to start using it and developing and building with it. But I would also tell you it's not yet ready for you to put into production. We're ramping up our serving capacity. And so today for production models, Gemini 2.5 is the answer, but very quickly, Gemini 3 is going to be ready for production use when we become generally available. Now, Gemini 3 is a state-of-the-art model. It tops the sort of industry standard benchmarks. Across almost all the benchmarks, you see Gemini 3 ranks #1. It's absolutely incredible in terms of its capability. It also provides this 1 million token context window, which has always been industry leading. Gemini has always been that model that provides, since the 1.5 days, which is a few lifetimes ago at this point, it's been providing this big context window. Now, if you're not sure what a context window is, let me help you out here. When you go and prompt a model, you provide it with some text, right? You provide it with a question or a problem to solve. But you might need to equip it with some extra information. That information might be additional text, right? Examples, you might have a single shot prompt or multi-shot prompt. You might have some media that goes with it, an image or things like that. And so all of that information, when you send it to a prompt, is context. And the context window is how much context does that model can it take every time you invoke it. And in the case of Gemini, we have 1 million tokens that you can do with it, that you can send every time you prompt the model. Now, again, 1 million tokens sounds like a big number. What does it mean in real terms? 2 hours of video. You can send a 2-hour video file in a single prompt. 11 hours of audio. Almost all of the Harry Potter books fit in that 1 million tokens as well. So it is a lot of context that you can send, and that's what makes the Gemini models incredibly versatile and useful. The other thing that we should keep in mind is that Gemini models are natively multimodal. That means that they actually understand not just text, but also code, images, audio, video. So you can pass all of those to Gemini as part of the context, and the model itself inherently understands that. You can pass it a video and say, at what point in the video was there a red envelope? And it will basically watch the video and be able to answer that for you. That's the level of capability that it has. But Gemini 3 is also one that we've built for amazing coding, for agentic coding. And this is why we also launched Google Anti-Gravity, our IDE, alongside it. Because this model takes us moving from beyond code snippet generation to system-level architecture. This model is capable of performing multi-file refactors and comprehensive software testing autonomously. It's also a great model if you're doing things like legacy code migration. By the way, legacy code migration is the #1 source of technical debt for enterprises. So amazing capabilities in this model. And the other thing that we did with Gemini 3 is that we know that agentic software is the future. So we've added capabilities to Gemini 3 that make it perfect for building agents. It has advanced tool use, so you can equip it with lots of tools. We're about to talk about tools in the next slide, about what they are and why they're important. But it has this advanced tool, but it also has this great capability of planning. So when you give Gemini 3 a task, it builds a plan first and then goes and tackles that task. It's not just making it up on the fly. It thinks ahead. All right, let's get back to talking about building agents with ADK. So ADK is, or rather agents are only as good as the tools that it can use. That model, the brain, is really important, but you need the tools. And we'll see why in a minute. ADK is designed to be flexible and it supports multiple tool types right out of the box. You can use simple functions that you want to call, you can connect to Google Search, and you can use powerful database tools with MCP as well. Again, we'll talk about MCP in a minute. Now, although this slide is showing you a Python logo, ADK is actually available for Python, for Go, for Java, and we have TypeScript coming soon as well. So it's really there for many of the popular languages around the world. Now, ADK isn't just good for building agents, but we added an entire deployment capability into ADK. So once you've built your agent, you've chosen your Gemini model and tools, deploying it is as simple as running one of these two commands. So the ADK tool set automatically includes a command for deploying to Cloud Run, ADK deploy Cloud Run. Or if you're already using Google Cloud and the G Cloud CLI, you can use call G Cloud Run deploy and point it to your ADK source code, and it will it'll package it, it will build it and deploy it. So with a single command, you get from local code on your machine to something that's scalable, that's secure, and is a publicly available endpoint. That's super, super convenient. All right, so we talked about building and deploying a single agent, and that's a great start. Let's expand on that. Let's talk about some of the additional protocols that help us build durable agent architectures. And we've talked about how the model is the brain of the agent itself. The tools are like the arms and legs of the agent. This is where it gets sources of information and it's able to perform actions. And if you look at every model out there, whether it's from Google or anyone else, there's a particular point in time where that model is trained. So the Gemini 2.5 models has a knowledge cutoff of January 2025. Anything that happened after January, those models don't know about it. Right? And that could be even new products that have been launched. ADK is something that we launched in April. So the Gemini 2.5 models don't even know about ADK, but it's the tools that allow you to bring more information in and augment your model that make your brain even smarter. And if you think about your own applications as well, you have data that you need to give to the models, whether that's something about your users, the capabilities of your particular application. It's just context that's specific to your business. That's where you can get the tools to provide that data to the models. So let's answer some critical questions. How do you let agents get access to this data? How do you let agents use tools and perform actions at scale? And how do you go from one to multiple agents without creating excessive chaos? That's where the Model Context Protocol, or MCP, comes in. To build durable agents, we need to have these three components right. The first one is the model, the brain, as we talked about. The second is the context. It's the real-world data and the tools that it needs. And the third is the protocol. How do you connect these things together? Now, MCP is an open source protocol that was built by Anthropic, and it's been adopted industry-wide. Developers can expose their data through MCP servers or build AI applications, which are MCP clients that connect to these MCP servers. Let's look at that. Your agent acts like an MCP client. Now, when it needs to use a tool, it makes a standardized call to an MCP server, and that MCP server then handles the secure interaction with the actual tool. Think of this like a universal adapter for your AI agents. And just to sort of reinforce the idea, think about this, like with our software today, these tend to be API calls that we make. We're calling it endpoints. And every time our software, whatever it is we're building, we need to call a new API, we have to write that code out. And every API is built differently. So you have to write bespoke code for every single API that you call. What MCP does is that if the vendor of that API builds an MCP server around it, and we'll see how to do that in a minute, then that MCP server can be consumed by any agent. That's not unique to ADK. There's other agent frameworks out there, like LangGraph, for example. They can all connect to MCP servers as well. So by having this layer of abstraction, the MCP server, I like to think of it as like USB-C for our API endpoints. If you think about USB-C, it's a standard plug that connects our phones, our batteries, our headphones, our watches, everything charges on MCP. We don't know what happens behind the scenes. Not on MCP, on USB-C. MCP is similar to USB-C, right? It standardizes that connectivity between client and server, and the MCP server handles how to actually call that API endpoint. So with MCP, you write that logic once in the server, and now any agent can use it. What that does for us all is that it accelerates our development. It handles all the tedious and repetitive tool calling that we have to do. And because it's an open standard, anyone can build or use MCP-compatible components. It's very flexible. So now, building an MCP server from scratch to handle all of your connections, all of your database connections, that can be pretty complex. So imagine you were doing that, right? There's a lot of work that goes into that, something like that. So we've made this easier with something that we call the MCP Toolbox for Databases. So Google's built this, but it is open source. And it already handles specialized tasks like connection pooling, like database authentication, like observability. That's all baked into the MCP Toolbox. And let's look at how what you have to do to build an MCP server with the MCP Toolbox. So here you'll see we have a YAML file, and we are declaring an MCP server here with the toolbox. So with our tool, we're declaring a tool, we're giving it a name, and this particular name is a little bit of a tongue twister. Look up available ability. So again, remember that example I gave you? We were building a video game character to take on fearsome monsters. This code is kind of part of that, which is why it's got some funny names. But all we have to do to declare to configure our MCP toolbox, give the tool a name, give it a description. And you'll notice that description is in natural language. You can read it the same way I can, and that's how the agent is going to read it. We didn't write any code here. We're saying look up all known abilities and their damage for a given familiar. That's the description. The agent will, the model will work it out. We provide some parameters. We say that in order to call this, we need to provide a parameter called familiar name, which is a string. We describe what that parameter is, and then we provide a SQL statement. That's it. We've now built an MCP server using the MCP toolbox. All of that complexity is going to be handled by the toolbox, and then we can go and deploy it. In this particular case, we're using gcloud run deploy again, the gcloud CLI. But by declaring this YAML file and then running this command, what this will do is it'll package up your code. It'll build an MCP server in an image, a container image, and it will go and deploy it to Cloud Run. You can specify which region it is in. You can provide some secrets as well if you've got API keys or username, passwords, and things like that. With that single step, we now have a secure, scalable resource and reusable toolbox that any agent in your organization can use. It's as simple as that. Now, many of us, our customers have asked us, how can they use generative AI for enterprise use cases? Now, as I mentioned earlier, foundation models are trained on publicly available data at a particular point in the past. They don't have access to your data. So Gen AI apps can answer with relevant and up-to-date information. They need to be able to augment that LLM with additional data. And the easiest approach to augment LLMs with data is through vector databases, because databases bridge the gap between foundation models and your generative AI applications. And this isn't just Google saying these things. Gartner published a report that said by 2026, 30% of enterprises will have adopted vector databases. We're about a month away from 2026. I don't know that they meant the 1st of January, but it's coming up soon. So 30% of enterprises will have adopted vector databases. They say more than that. They say that more than 70% of natural language use cases will use vector databases to ground the AI models. And more than 60% of vector database deployments will be cloud-based managed services. So this is a big deal. The industry is moving forward. And at Google Cloud, we have an incredible suite of databases that provide the foundation for building innovative and intelligent applications that can transform your business. As you can see, we have a database for every need, from structured to unstructured, from transactional to analytical. Our databases support various data models, including relational, in-memory, document, and key value, which provides you as developers flexibility to choose the best fit for your specific needs. And we have compatibility with a wide range of technologies, including open source and commercial, so it allows you for easy migration and integration. But here's the real kicker. These databases, they're not standalone silos. They're designed to work seamlessly together, and they're deeply integrated with Google Cloud's AI platform, known as Vertex AI. So this is how you build agents with Google Cloud. Our yellow box is our actual agent code. I'm going to point to that one there. I won't be able to point. Our yellow box there is our agent code. On the top right there, you can see the models that we use, the Gemini models. You add tools with MCP, as well as some built-in tools that ADK already offers. But ADK also gives you added security and observability out of the box. So it's not just about writing code, but it's about having production-ready deployments to go, and ADK gets you there. All right, let's take a moment to dive into Cloud Run, because it is the ideal runtime for everything that we've been talking about. Cloud Run is a fully managed platform for deploying and scaling serverless containerized microservices. The cool thing about Cloud Run is that it rapidly and securely scales on Google managed infrastructure. You don't need to manage the infrastructure itself. It connects seamlessly to your entire development lifecycle, from coding and building to deploying and operating. And we provide built-in connectors for Google Cloud's data, security, and AI services. For AI agents specifically, Cloud Run is ideal because it solves all of the big problems. Remember those questions that we asked at the start for app developers and platform builders? Well, Cloud Run scales from 0 to thousands of instances. So you only pay for what you use. And that's really important because, especially for AI, it's critical for AI, your costs can be quite unpredictable. You don't have to worry about infrastructure. It's enterprise ready and it's highly available. And it's designed to make your life as a developer easier because it has built-in credentials. So you don't have to manage API keys to call Google APIs like the Gemini API. You also have the freedom to use any framework and any language. It's entirely agnostic in terms of how you use what you can deploy onto Cloud Run. And Cloud Run gives you a secure, streamable HTTPS endpoint. That's right, HTTPS. We even provision the SSL certificates for you so that you can make sure that your transport is encrypted. Now, when you put all of this together, you end up with a platform that developers genuinely love, which is why it consistently earns top satisfaction scores. But don't just take my word for it. Nuno Campos, who's a founding engineer at LangChain, said that Cloud Run is the easiest and fastest way to get your LangChain app running in production. The folks at LangChain see the same thing that we at Google do. It just works. And for workloads that need a serious performance boost, Cloud Run also offers GPUs. So now you get the best of both worlds. You get the raw power of accelerator hardware, but you get the simplicity and pay-per-use aspects of serverless. All right, there's one last thing I want to talk to you about. And I think that this thing is going to be super helpful to you over the next 2 days as you build. It's the Gemini CLI. How many of you have used Gemini CLI? Only a few. So I'm really excited for those of you that have not used it, actually, because Gemini CLI is one of my favorite tools. And I have my team members here that work on different products. So I hope they don't tell my other team members that this is my favorite, because I'm not supposed to pick favorites. But anyways, Gemini CLI is an open source AI tool that lives in your terminal and is designed to help you write code, automate tasks, and debug issues. You can equip the CLI with your own system instructions and custom commands so that it understands your project. And you can also connect it directly with the MCP servers that you want to use or ones that you create. So as you start building, I recommend you try using the Gemini CLI first. It's a fantastic way for you to stay in your flow and to solve problems faster. And we also added a Cloud Run Gemini CLI extension. And because of that extension, the deployment process becomes simple. You have this one-time setup of installing the extension and authenticating with Google Cloud. But after that, you just have to call /deploy to deploy your application to Cloud Run. So imagine you're sitting there coding away and you want to test these changes with a publicly available endpoint. You just call /deploy. It will build it, package it, deploy it onto Cloud Run. You'll have a publicly accessible URL. It's super neat that way. So from a prompt in your terminal to a live application, Gemini will understand your code, package it up, and deploy it. It's super exciting. Phew, we've talked about a lot today, right? We've seen how you can build powerful agents with the ADK. We've seen how you can architect them for scale with MCP and Google Cloud databases. And we've seen how you can run it all on Cloud Run, which is the simplest and fastest serverless platform. So over the next 2 days, you're going to get to go hands-on with all of these tools. Now, we have some amazing TAs, technical assistants here. So can I just get folks to put up their hands, the TAs? We've got the 5 of us here that are here to help you. We're here to unblock you. We're here to see the amazing things that you create. Ultimately, what I want you to realize is that you have the tools. You have the platform. Most of all, you have your ideas. It's time to get building. Thank you and have a fantastic marathon.
Thank you so much, Ankur. And I hope you all took a screenshot of the architecture slide that was on when Ankur was speaking about the powerful data stack and the AI stack that we have on Google Cloud. Even if not, we'll that was sent to you. If you've all looked at the emails that was shared with you, the information that it had the architecture diagram of all the things that you can cover during this time. And remember to use Gemini CLI even if you're blocked, because we will request you to use Gemini CLI as your first point of technical expert that can support you and get you to unblock whatever is blocking you until that point. So next up, we have a hands-on session right now. So I would invite Alvin and Joanne over. Molly, is there anyone in the room that does not speak the local language? Okay, we have one person over here. So we'll do an English introduction. Molly, you want to do the honors? Just give a brief about what we are covering in the hands-on, and then Alvin will take over. Or am I putting you on the spot? Oh, no worries. I mean, he's going to connect anyway. So he's just going to put the introduction slide on. Or if you want to do that in English first and then do the local language.
I think it's just do it in Bahasa.
Bahasa, there's one person who's not speaking English.
Okay.
Okay. So yeah, for you, we will do an introduction in English, but after that, the lab is in English. So if you don't follow the instructions here, please go through the step-by-step instructions in the lab. So it should be self-explanatory. If not, just put your hand up. I'll walk over. One of us will walk over and help you out. Yeah. So the other folks, you're all comfortable with the local language instructions, right? Yeah, cool. I'm confused. So who's doing the introduction? What are you doing it?
It doesn't matter to me. I'm just pulling up the lab.
Oh, he's going to show the lab anyway. He's putting the introduction slide up.
Okay.
Here is. Sorry,
It's okay. I just would have had it ready.
Just give them instructions.
I would like to open this.
Oh, the lab.
Yeah.
Yeah. What is the
Are you just, when you say do an introduction in English, are you just saying like give an overview of what the lab is?
What the lab is, that's it. Just an introduction of what the lab is.
Great.
That's why it's good.
Yeah. Well, I know, but I went into the lab so that I could get.
Yeah.
So Alvin will be going through the lab in a bit.
yes.
Basically, with this lab, you're going to be deploying. You're going to be creating an ADK agent and deploying it to Cloud Run with a GPU. One of the first steps that he'll go over is that's important. And so if you need help and don't speak the local language, flag me down. But basically getting set up with the proper billing is very important. It's a thing that can get people tripped up. I think you should have gotten a link that will give you access to a special billing account.
Can I just show one thing before you
If
go
you've
on?
done,
Sure.
if you've used some of those like credits in the past, this is a special credit that has like more money on it than normal ones because of what this lab is doing. So if you leave it on an older credit, you'll run out before you're done with the lab. So it's worth knowing that and making sure you set up with the new credit that is for this lab. Yeah. Oh, yeah. And so the two things that are done for this lab are deploying a Gemma backend to Cloud Run, so a local model, and then also deploying an agent, an ADK
You have
agent.
it?
Okay.
And those two things will then be working together. I think that's the basic overview. Yeah.
That's pretty much it. Thank
Great.
you. Thanks,
Yeah.
Thank you. So yes, Alvin, over to you.
Okay, thank you, Abby. Thank you, Molly. Okay, so yeah, maybe for the first part, I'll try to explain in English first. For you who maybe have some difficulties to follow in Bahasa, the workshop part, the tutorials is written in English. But if you have some questions, feel free to raise your hand so that our TA can reach out to you and support you with the problems that you have. Okay. Okay, so I'll switch to Bahasa now. Oke, teman-teman, jadi di workshop kali ini kita akan mengeksplorasi bagaimana kita itu membuat suatu AI agent berbasis ADK, tapi yang dimana dia akan menggunakan Cloud Run GPU itu sebagai suatu media untuk menjalankan open model yang kita pilih, gitu. Jadi mungkin ini untuk teman-teman yang sebelumnya pernah mengikuti workshop menggunakan ADK atau mungkin workshop menggunakan Gemini Shell atau yang lain. Nah, biasanya kan kita menggunakan model Gemini di situ. Nah, di dalam workshop kali ini, kita akan menunjukkan bagaimana teman-teman itu memiliki pilihan atau memiliki opsi kalau teman-teman itu tidak prefer dengan model yang di-serve menggunakan API. Atau mungkin ada masalah compliance issue, atau mungkin saya ingin merasa lebih secure kalau saya mempunyai pengaruh lebih lah terhadap model-model yang di-deploy. Nah, di dalam lab ini, kita akan menunjukkan bagaimana teman-teman dengan mudah bisa menjalankan open model yang teman-teman pilih, mungkin model seperti Gemma, atau MedGemma, atau mungkin lebih prefer menggunakan model lama, Qwen, dan model-model yang lain, dengan menggunakan Cloud Run sebagai media untuk menjalankan model tersebut. Gitu. Nah, sebelumnya mungkin saya ingin memperkenalkan diri lagi. Nama saya Alvin Prayuda, dan saya merupakan Developer Relations Engineer untuk Regional Southeast Asia, khususnya di Indonesia. Oke, nah selama tutorial yang akan kita lakukan ini, kita akan menjalankan step-step kurang lebih seperti di 4 halaman ini. Jadi yang pertama adalah teman-teman akan mendeploy otaknya dulu, ya kan? Tadi kan kita nggak pakai Gemini untuk otaknya, jadi kita akan mendeploy open model menggunakan Gemma di sini, dan dia akan di-run menggunakan GPU NVIDIA L4 yang ada di Cloud Run. Gitu. Dan yang kedua, kalau punya otaknya doang, kan cuma bisa ngobrol via API ya, yang mana akan susah kan ya, kalau misalnya kita harus setup HTTP dulu, nembak dan sebagainya. Nah, kita akan memberikan dia interface menggunakan ADK, Agent Development Kit, yang dimana di ADK itu nanti teman-teman juga akan sudah punya built-in interface menggunakan web development UI yang disediakan oleh ADK, sehingga bisa langsung coba ngobrol tuh ketika ADK-nya sudah connect ke Gemma-nya tadi. Gitu. Nah, kemudian yang paling terakhir, karena kita membahas tentang production environment ya, di mana teman-teman mungkin akan perlu nge-tweak resource, melihat seberapa tahan nih service yang sudah di-deploy, kita akan mencoba untuk melakukan stress test terhadap aplikasi yang kita deploy. Gitu. Nah, untuk simplicity, nanti kita akan lihat detailsnya di tutorial yang setelah ini akan saya share ke teman-teman. Tapi kurang lebih secara gambaran garis besar adalah seperti ini, proses yang akan dilakukan. Oke. Nah, secara arsitektur kita akan mendeploy 2 service seperti yang dilihat di sini. Jadi Gemma-nya sendiri yang merupakan otak dari LLM itu akan menjadi suatu cloud run service sendiri ya, yang dijalankan dengan menggunakan framework Olama. Nah, kalau yang belum pernah tahu Olama itu apa, nanti kita akan jelaskan di slide berikutnya. Tapi sejauh ini ada yang pernah nyoba Olama belum? Sendiri. Oke, 1, 2, 3. Oke, udah ada at least. Udah pernah ngoprek-ngoprek berarti ya. Nah, lalu yang kedua adalah untuk connect ke sini, kita juga akan punya service sendiri, ADK, yaitu dia akan dijalankan dengan menggunakan bahasa Python di atas framework Fast API, dan perbedaannya adalah Gemma-nya akan menggunakan Cloud Run yang memiliki GPU di dalamnya, sedangkan yang ADK itu hanya CPU only aja. Gitu. Jadi arsitektur ini adalah reference arsitektur ketika teman-teman mendeploy model sendiri, lalu ingin punya suatu agen mengutilisasi model tersebut itu dalam skala yang besar. Jadi di sini misalnya teman-teman nanti punya agen customer service atau nanti punya agen internal tooling sendiri, mereka sebenarnya bisa connect ke otak Gemma instance yang sama selama kapabilitas resource-nya masih kuat untuk menghandle traffic dari service-service tersebut. Gitu, sehingga punya kebebasan untuk mengatur scalability-nya. Nah, ketika kita mencoba untuk nge-dev lebih dalam lagi, apa aja sih stack-stack yang akan kita pakai? Jadi untuk stack agent-nya sendiri kita akan menggunakan ADK, Agent Development Kit ya, framework agent yang akan kita gunakan untuk mengatur sistem prompt-nya seperti apa, tools yang dipakai seperti apa, settingan thinking-nya seperti apa, gitu ya. Nah, dan untuk connect ke Gemma-nya sendiri, gitu, kita akan menggunakan framework yang bernama Light LLM. Gitu. Kalau tadi sebelumnya Anchor bercerita dengan teman-teman bahwa MCP itu adalah USB-C yang bisa menghubungkan service apapun dengan AI agent yang teman-teman buat dalam framework apapun, gitu ya. Nah, kalau alat LLM ini merupakan USB-C kalau teman-teman ingin menggunakan model yang berbeda-beda dengan satu framework yang sama, gitu. Jadi teman-teman pakai ke Gemini pun pakai alat LLM juga bisa, mau ganti ke model Gemma juga bisa, yang menggunakan Olama juga bisa, atau mungkin nanti teman-teman explore lain yang menggunakan VLLM contohnya atau menggunakan provider lain, itu juga bisa dengan mudah dikonfigur di Light LLM ini, gitu. Dan yang terakhir, Light LLM-nya nanti akan connect ke Olamanya, yaitu yang merupakan framework untuk nge-serve model dari LLM yang akan kita gunakan, sehingga teman-teman bisa punya kontrol penuh terhadap model yang teman-teman deploy di dalam Cloud Run nanti, gitu. Oke, ini tadi merupakan gambaran agent development kita itu untuk provide apa aja ya. Tadi sudah dijelaskan secara singkat oleh Anchor. Tapi mungkin di sini saya pengen emphasize lagi bahwa ADK ini merupakan framework agent yang akan membantu teman-teman untuk mendeploy dan memanage agent yang teman-teman punya, khususnya terintegrasi dengan Google Cloud. Jadi teman-teman bisa punya berbagai macam pilihan untuk menyimpan conversation memory, menyimpan session, state, artifact gitu ya. Atau kalau misalnya teman-teman pun ingin tahu terhadap performa lebih dalam dari agent-agent yang teman-teman punya, juga disediakan untuk local view untuk melakukan debugging, tracing, dan berbagai macam fitur-fitur yang lain. Nah, sedangkan Olama sendiri, kenapa sih kita prefer pakai Olama di dalam tutorial ini? Karena ini sebagai entry point teman-teman untuk mencoba sendiri dan merasakan bagaimana mendeploy LLM pertama di lokal teman-teman dulu, lalu kemudian kita bawa ke cloud untuk menskalakannya. Gitu. Nah, ketika teman-teman menggunakan Olama, meskipun nanti ketika di-deploy, teman-teman juga akan terhubung via API ya terhadap Olama tersebut. Nah, tapi Olama ini memastikan bahwa teman-teman itu bisa mendeploy open source model apapun itu dengan mudah. Gitu. Ketika kita berbicara tentang open source model, dia itu bisa ditulis dalam framework yang berbeda, misalnya bisa ditulis pakai PyTorch atau mungkin pakai TensorFlow. Cara interaksi dengan modelnya secara raw itu juga berbeda-beda. Nah, Olama ini semuanya meunifikasikan hal tersebut dan seakan-akan nge-wrap ya LLM tersebut itu terhadap suatu backend service yang siap dipakai, yang dimana itu sudah terintegrasi langsung nanti dengan Light LLM. Gitu. Cara deployment-nya pun lumayan mudah, teman-teman juga bisa mengatur tuh dalam konfigurasi Olamanya sendiri kira-kira untuk bisa ngehandle dengan resource GPU yang digunakan, berapa banyak request paralel yang bisa diatur, dan berbagai macam konfigurasi-konfigurasi lain. Jadi kalau misalnya teman-teman coba secara lokal pun tinggal download modelnya, lalu setelah modelnya selesai di-download, teman-teman nggak butuh internet lagi untuk mencoba large language model tersebut running di komputer teman-teman. Dengan catatan laptopnya kuat ya. Kalau misalnya laptopnya udah lama nih, terus habis itu dia GPU-nya ngos-ngosan, misalnya ngeran Gemma yang 7B gitu ya, wah itu hati-hati panas aja sih laptopnya gitu. Oke? Nah sekarang untuk hands-on, untuk teman-teman yang sebelumnya mungkin belum ngeklaim ya, jadi ini saya tampilkan lagi, URL-nya ada di sini. Tolong difoto untuk teman-teman yang belum ngeklaim, atau kalau misalnya yang sudah ngeklaim, kita tunggu dulu untuk teman-teman yang belum ngeklaim di sini. Karena ya mungkin teman-teman di sini sudah ada yang mencoba atau mengikuti sesi hands-on workshop di sesi sebelumnya dan sudah pernah ngeklaim kredit yang sama. Nah, seperti yang tadi disampaikan oleh Molly, di sesi ini karena kita butuh utilisasi GPU, maka kita perlu menggunakan kredit yang mensupport untuk penggunaan GPU tersebut. Gitu. Jadi pastikan teman-teman sudah menyimpan URL ini, dan untuk cara setupnya nanti akan saya tunjukkan ya secara singkat. Teman-teman juga bisa mengakses tutorialnya di Google Hands-on Setup di sini. Oke. Di sini ada yang belum ngeklaim kreditnya atau udah semua? Oh, masih banyak ya. Oke. Jadi udah, kalau sudah difoto, nanti ketika teman-teman untuk yang belum ngeklaim, kurang lebih stepnya seperti ini ya. Jadi dibuka dulu halaman claiming cloud credits-nya, lalu nanti akan ada kupon yang bisa di accept oleh teman-teman. Nah, lalu setelah kuponnya di accept, teman-teman perlu untuk membuat project dan memastikan bahwa project-nya itu sudah ke-link dengan billing account yang barusan diklaim. Gitu. Jadi untuk tampilan awalnya, nanti akan muncul ke halaman seperti ini. Ya, nanti tinggal diklik aja, klik here to access your credits. Kemudian pastikan bahwa ketika teman-teman masuk ke proses untuk nge-redeem billing account-nya, teman-teman ngelihat bahwa akun email dan kupon code-nya itu ke gray, disable ya, warnanya jadi abu-abu lah, kurang lebih gitu. Kalau misalnya belum, warnanya somehow tidak abu-abu dan bisa diedit, kemungkinan teman-teman sudah ngeklaim kredit tersebut, atau nanti kalau misalnya yang ada kebingungan atau isu, tinggal angkat tangan aja, nanti coba kita bantu cek kira-kira isunya gimana. Nah, kalau udah selesai, bisa langsung klik accept and continue. Nah, kemudian teman-teman bisa pergi ke halaman Cloud Console, either by ngeklik icon Google Cloud ya di kiri atas, atau langsung pergi aja ke halaman console.cloud.google.com. Oke. Nah, selanjutnya teman-teman bisa ngecek untuk verified apakah billing account-nya itu udah aktif atau enggak. Nah, ini kemungkinan karena namanya sama-sama trial billing account ya. Jadi nanti teman-teman yang sebelumnya sudah pernah ngeklaim cloud credits akan masuk ke halaman seperti ini, link billing account. Nah, ini nanti dia akan muncul namanya trial billing account, Google Cloud Platform trial billing account. Hah? GPU. Oh, really? Oke. Ada yang error ngakses URL untuk claiming credits-nya tadi? Jakarta. Ada yang bermasalah ngakses halaman ini? Aman. Oke. Oke. Yes. Ya. Iya, betul. Kalau teman-teman sebelumnya udah pernah ngeklaim kredit ini, dipastikan ketika mengakses billing dan mengakses halaman credits, angka yang keluar adalah $10. Oke. Dan pastikan ketika teman-teman membuat project baru, project ini pun terhubung dengan billing account tersebut. All good semuanya? Ada yang masih butuh bantuan?
What the questions here for activation? How many of you were able to successfully get the project in a newly created account? Please. No, not yet. You have questions? No? Activated? Linked? My friends have what expired? No, probably it means they're already in the campus.
Oh, dia kan ya. Yang pasti kan dia paling yang atas. Namanya sama sih, tapi kalau misalnya ini bisa saya buat di cek aja. Kalau udah project itu.
Oke, this is.
Memang butuh create project. Oh iya.
Ya, untuk teman-teman yang bingung kalau misalnya nggak ada pilihan link link billing account atau waktu create project kok nggak ada pemilihan billing account gitu ya, tapi udah berhasil nge-redeem, nggak usah khawatir karena biasanya itu projectnya akan langsung otomatis ke link dengan billing account yang aktif. Oke. Oke. Ada yang masih ada isu? Oke, looks good. Let's continue then. Oke. Jadi pastikan teman-teman yang tadi udah berhasil ngeklaim buat cloud project baru ya. Lalu dipastikan juga cloud projectnya itu udah ke link dengan billing account yang barusan teman-teman redeem.
The folks who already have, so we had one issue right here. That they already had a $5 billing account which was expired or half used or something like that associated to the project that they wanted to use for this handoff. However, know that the $5 billing account, even if unexpired, will not be eligible for the GPU enabled code lab that we're going to use right now. So the code lab is not GPU enabled, you know what I mean. The use case uses GPU. So what you have to do is, first of all, go to the $10 billing account by just going to all billing accounts and rename that to something that you can identify as a $10 billing account. Because all our trial billing account links will have the same name. It will say trial billing account. Okay, so it's confusing. You will not know which one. So rename the $10 billing account to something that you can identify uniquely. Yeah. Then go back to the project that you want to work on hands-on and go to the manage billing accounts option. Choose your projects. And in your project, there will be a vertical ellipsis, like 3 vertical dots in the right side corner, right up corner. Click that and choose the change billing account option. Once you change that billing account, you'll be able to see the newly renamed $10 billing account and pick that one. So you have to make sure your active project should be linked to the active $10 billing account. Only then this code lab, the code lab will work either way, but then the last step where you have to deploy will fail if you're using a $5 billing account. So you have to use a $10 billing. Yeah. Thank you.
Ya. Untuk teman-teman yang bingung cara ngegantinya seperti apa ya. Jadi pertama ketika teman-teman masuk ke billing account kan ngecek di sini ya. Ada di credits. Lalu pastikan yang untuk lab ini teman-teman mengaktifkan yang original value-nya $10 di sini. Nah, lalu ketika teman-teman ingin nge-rename, scroll down ke bawah dan kemudian ada account management di sini. Ini diklik aja. Nah, kemudian ada tombol untuk rename billing account dari sini. Oke. Bisa diklik aja, lalu diedit di sini sesuai dengan yang teman-teman inginkan ya. Kalau rekomendasi dari saya, biasanya saya tambahin prefix GPU di atasnya, supaya masih aware bahwa ini trial billing account dan bisa menggunakan akses GPU. Oke. Oke, yuk untuk majority I think has no issue ya. Jadi kita lanjut dulu untuk sekarang. Jadi selanjutnya teman-teman bisa pergi ke CodeLab ini, codelabs.developersgoogle.com atau URL-nya yang ada di email yang teman-teman terima ya. Kalau misalnya yang bingung cara mengaksesnya gimana, bisa ke halaman codelabsdevelopersgoogle.com dan kemudian cari lab 3. Nah, nanti dia akan ada di bawah ini. Prototype to production, deploy your ADK agent to cloud run with GPU. Oke. So far bisa ketemu CodeLab-nya? Kan ya? Oke. Oke, nah. Jadi kita akan langsung mulai aja di CodeLab ini. Bisa langsung ke sesi nomor 2 ya, untuk project setup. Tadi teman-teman pastikan punya project yang terhubung dengan billing account masing-masing. Nah, kemudian untuk interaksi CodeLab ini, kita akan masuk ke Cloud Shell Editor. Jadi kalau Cloud Shell Editor ini ke setup nomor 3, teman-teman bisa langsung diklik aja di sini untuk link ke Cloud Shell Editor-nya. Atau teman-teman bisa langsung memasukkan shell.cloud.google.com. Oke. Nah, ketika teman-teman di request untuk authorize Cloud Shell seperti ini, bisa langsung diklik authorize saja. Tuh. Nah, nanti ketika teman-teman masuk ke Cloud Shell Editor, kalau pertama kali baru masuk, biasanya dia akan muncul 2 interface ya. Jadi yang interface atas itu Cloud Shell Editor, lalu yang interface bawahnya itu Cloud Shell Terminal. Itu bisa di close salah satu aja, supaya tampilannya jadi Cloud Shell Editor seperti ini. Lalu kemudian yang perlu dilakukan adalah kita buka terminal baru di situ. Jadi .3 ini di sini, diklik terminal, lalu choose new terminal. Oke. Nah, kemudian kalau misalnya sudah selesai, kita perlu nge-config terminalnya tersebut supaya aktif dengan project ID yang baru kita gunakan. Jadi teman-teman bisa running pertama-tama kita list dulu ya project yang barusan kita buat supaya dapat ID-nya berapa. Tinggal copy ini aja, G-Cloud Project List, AWK, dan dapetin pattern-nya. Kemudian di paste di sini. Nah, nanti akan muncul list dari project-project ID yang teman-teman punya. Nanti tinggal dipakai aja project ID yang barusan teman-teman buat. Gitu. Jadi setelah aktif di sini, tinggal dilakukan di cloud config, set, project, nama project ID yang teman-teman punya. Oke. Nah, kalau misalnya terminalnya sudah aktif dengan konfigurasi project ID yang sesuai, nanti dia akan ada tambahan value ya di terminal teman-teman seperti ini. Kalau di saya karena pakai dark theme, jadi warnanya kuning. Dia ada project ID-nya nongol di terminalnya. Ini berarti udah konfigurasi dengan baik. Nah, selanjutnya, kalau misalnya sudah selesai, kita bisa lanjut ke step nomor 4. Tapi sejauh ini sampai step nomor 3 ada yang encountering an issue? All good? Oh, sabar aja Mas, itu biasanya connection issue. Mau ditunggu ya Mas ya. Biasanya kalau misalnya sebelumnya belum pernah buka Cloud Shell Editor atau Cloud Shell Terminal, memang butuh beberapa menit biasanya ya untuk nge-instantiate resource-nya dulu. Oke. Ada yang udah sampai kebuka Cloud Shell editornya? Coba boleh angkat tangan dan udah config project-nya, oke ya? Oke, sip. Oke. Ada yang butuh bantuan? Boleh angkat tangan? All good? Oke. Ya, mungkin tunggu beberapa menit dulu. Kalau nggak coba di refresh lagi. Nah, selanjutnya kita bisa ke step 4 ya. Jadi di step 4 ini, karena kita akan menggunakan beberapa service dari Google Cloud Platform, yaitu Cloud Run dan Gemini, kita perlu untuk mengaktifkan beberapa API-nya dulu. Jadi di sini kita tinggal run aja komennya, di Cloud Service Enable. Jadi yang kita aktifkan di sini adalah Cloud Run Service, Artifact Registry Service, Cloud Build Service, dan Vertex AI Service. Nah, kenapa kita masih butuh Artifact dan Cloud Build? Nah, karena Cloud Run itu nge-package semua proses-proses yang diperlukan untuk teman-teman mendeploy aplikasi teman-teman ke cloud. Jadi nanti dari source code yang teman-teman punya akan di-build Docker kontainernya atau Docker image-nya menggunakan Cloud Build. Kemudian Docker image yang sudah di-build itu tadi nanti akan di-push ke Artifact Registry. Nah, nantinya service Cloud Run akan mengambil base image dari Artifact Registry tersebut untuk mendeploy aplikasi yang teman-teman punya. Oke. Jadi di copy di sini untuk di-enable di sini ya.
Jadi kayak image Docker-nya itu dari Cloud Build taruh ke Artifact yang itu biar bisa di-run gitu.
Iya, betul. Itu semuanya sudah ada di komen Cloud Run nanti yang akan kita deploy. Nah, kalau misalnya udah selesai, nanti akan ada notifikasi seperti ini, teman-teman. Jadi, operation successfully.
Image-nya isinya service apa itu?
Nah, nanti akan kita lihat, Mas, di belakang. Oke, kalau misalnya sudah selesai, langkah selanjutnya yang kita perlu lakukan adalah di dalam tutorial ini kita akan menggunakan region Europe West. Ya, jadi teman-teman perlu ngeset untuk terminalnya supaya dia aktif di region Europe West. Jadi kita copy komennya di sini dan running di sini.
Ini region harus Europe West atau boleh?
Untuk sekarang untuk tutorial kita ikutin Europe West dulu, Mas. Oke. Alright. Nah, kalau misalnya udah, kita akan mulai mempersiapkan Python project kita. Jadi untuk tutorial ini, kita udah ada repository yang udah disiapkan untuk teman-teman bekerja di repository tersebut. Jadi kita akan melakukan cloning menggunakan Git, dan pastikan direktori nanti yang aktif di terminal adalah sudah di dalam repository yang barusan di-clone tadi ya. Tinggal di copy dan paste di sini. Oke. Oh, ini di kasus saya udah ada direktorinya ya. Dan saya udah masuk ke direktori yang sebelumnya udah saya siapkan. Tapi mari kita ulang lagi aja deh. Oke, dan lalu run ulang. Oke. Nah, ketika teman-teman udah selesai proses cloningnya, nanti teman-teman cek dengan command ls-r, harusnya sudah ada satu readme file dan 2 direktori, yaitu satunya direktori adalah Olama backend, yaitu service tempat kita akan ngedeploy Gemma model, dan kemudian agentnya di direktori edk agent. Oke. Oke. Nah, selanjutnya kita akan mulai ngelihat di step 7. Jadi di sini kita akan mulai melakukan deployment Gemma di atas Olama tadi ke Cloudrun. Dan yang perlu kita lihat di sini adalah pastikan teman-teman sudah masuk ke direktori Olama backend dulu. Lalu kemudian kita perlu untuk membuat Docker filenya, gitu. Jadi Docker file ini itu merupakan blueprint kita untuk membuat service atau nge-up service Olama ini ke Cloudrun. Jadi kita running dulu. Kita masuk ke cd Olama backend. Dan kemudian kita running command cloud shell edit. Ini kalau di cloud shell, command ini tuh akan membuat file baru dan langsung membuka filenya di editor teman-teman nih, seperti ini contohnya. Jadi ini udah dilihat, dan pastikan Docker filenya benar ya, di dalam direktori Olama backend, di dalam repo yang tadi barusan di clone. Kemudian yang dilakukan tinggal di copy paste konten dari Docker file ini ke sini. Oke. Nah, jadi tampilannya bisa teman-teman lihat di sini. From Olama latest, kita set Olama hostnya, models, debug, dan keep alive-nya. Kemudian kita configure model Gemma 3-nya, dan kemudian dari Olama sendiri, kita akan minta Olama untuk nge-pull model weight atau data-data yang diperlukan untuk mendeploy Gemma model ini. Oke. So, let's do this. Command untuk deployment-nya, teman-teman bisa scroll agak ke bawah ya. Ini di copy aja langsung. Lalu di paste ke Cloud Shell tadi, di terminal. Oke. Nah, proses untuk deployment ini akan memakan waktu beberapa menit. Ya, jadi sambil dia menjalankan proses deployment-nya, kita akan lihat sebenarnya di command Cloudrun-nya itu ada apa aja sih yang kita lakukan. Ya. Nah, jadi cara teman-teman untuk mendeploy aplikasi ke Cloudrun itu bisa bermacam-macam. Teman-teman bisa mendeploy dari as a function, bisa mendeploy dari source code. Misalnya teman-teman punya file Python, file Java, ngedeploy dari source code langsung dari language-nya main.py-nya, itu bisa. Kalau yang di sini yang kita lakukan adalah kita sudah nge-provide Docker file-nya. Gitu. Jadi ketika udah punya Docker file-nya, di flag /source.titik itu berarti kita nge-pinpoint bahwa Docker working directory-nya adalah di directory yang waktu itu sedang aktif di terminal. Gitu. Lalu kita masukkan juga, kita akan deploy di region Europe West 1, karena salah satu region yang sudah ready untuk Cloudrun GPU-nya. Kemudian kita akan mengeset bahwa aplikasi Cloudrun ini, yang ada Olamanya, kita set concurrency-nya ke 7. Yang berarti apa? Nah, ketika kita mengeset concurrency 7, ini kita mengatur bahwa ketika ada 7 parallel request masuk ke service tersebut, kita minta dia itu untuk scaling up. Jadi nggak bisa lebih dari 7 parallel request yang masuk ke service tersebut. Gitu. Nah, nanti ini teman-teman bisa nyoba ya di luar tutorial ini. Karena di tutorial ini, karena resource GPU itu mahal dan kredit yang teman-teman punya juga terbatas, kita ngelimit max instances-nya sama dengan 1 tuh di situ. Ini bisa kan? Oke, ya. Banyak instance dari Cloudrun-nya, service-nya, gitu. Kalau mungkin familiar dengan istilah replika, ya. Jadi replika instance-nya itu cuma 1 aja. Nah, dengan skenario let's say kita nggak set max instance-nya 1 gitu ya. Misalnya itu argumennya dihapus. Nah, let's say teman-teman melakukan stress test nih ke Olama backend ini, misalnya 60 user di dalam waktu bersamaan. Nah, nanti dia akan nge-scale banyak instance-nya itu lebih dari 1. Tapi karena ini instance menggunakan GPU, berarti let's say instance-nya itu ke replika jadi 4 instance. Ya berarti teman-teman juga ngeran 4 GPU di waktu tersebut. Yang makanya cost-nya akan menjadi lumayan costly sekali. Gitu. Oke.
Virtual komputer gitu.
Iya, semacam VM yang sudah di-manage oleh Google. Oke. Nah, jadi teman-teman di sini juga sudah lihat di komennya kita juga specify GPU type-nya NVIDIA L4. Kita mengatur environment variable juga. Jadi kalau di Cloud Run, teman-teman pengen ngeset environment variable, misalnya contohnya untuk deployment pertama kali gitu ya, itu flag yang bisa dipakai, dash set envars. Nah, lalu dimasukkan aja environment variable-nya seperti apa. Di sini kita kasih contoh Olama 6 paralel sama dengan 4. Oke. Nah, ketika kita ngeran proses building Cloud Run-nya sendiri, kita bisa lihat nih sebenarnya step-step yang dilakukan itu ada apa aja. Jadi yang pertama, yang paling atas ya, kita pertama nge-upload dulu sources-nya. Kemudian setelah uploading sources, mungkin untuk teman-teman tadi waktu nge-run deployment-nya diminta persetujuan ya, bahwa artifact service registry akan di-enable di reguen tersebut ya. Nah, itu berarti dia juga sudah menyiapkan pada saat proses build container, dia udah menyiapkan nih. Nanti setelah kontainernya selesai di-build, image-nya selesai di-build, itu akan di-push ke artifact registry di project dan region yang teman-teman pilih. Gitu. Nah, setelah proses uploading Docker image-nya selesai, nah nanti Cloud Run akan ngambil artifact image tersebut, lalu dia akan nge-up artifact tersebut menjadi suatu Cloud Run service dalam case ini. Nah, Cloud Run nantinya juga akan mengatur bagaimana untuk mengatur revision. Jadi ada versi-versinya nih dari service yang barusan di-deploy, mengatur traffic-nya, routing-nya seperti apa, dan juga nge-configure kira-kira autorisasi untuk mengakses aplikasi tersebut itu seperti apa. Gitu. Nah, nanti kalau misalnya sudah selesai, seperti contoh di sini ya, teman-teman bisa lihat, teman-teman udah punya public URL yang bisa diakses di web browser manapun dari HP teman-teman juga bisa, bahwa ini sudah up untuk model Olama yang barusan kita deploy. Gitu. Nah, contohnya seperti ini. Ini karena saya mengakses health check-nya dia ya, jadi responsnya cuma seperti ini aja. Oke. Untuk teman-teman di sini, ada yang udah berhasil ngejalanin proses deployment-nya? Ada kendala mungkin? Kita tunggu beberapa menit dulu untuk proses build-nya ya.
Jadi Olamanya ini cuma buat nge-load modelnya doang.
Ngedownload dan menjalankan model open modelnya itu sebagai suatu HTTP service.
Ini kan asumsinya nanti jadi penggantinya otaknya. Ini kan otaknya.
Iya, betul.
Itu berarti EDK-nya lain lagi kan?
Iya, ODK-nya akan di service yang terpisah. Oh, 5 menitnya ya. Itu sebenarnya dari dari kualitas koneksinya juga. Jadi gini, Cloud Run di sini ketika masnya ngedeploy Docker file, dia kan harus nge-pull dulu dari Docker Hub. Karena image base-nya yang tadi Olama bla 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 itu kan ada di Docker Hub. Setelah dia selesai nge-pull, kita juga di Docker file-nya ada instruksi untuk nge-download modelnya. Nge-download modelnya itu yang lama. Gitu. Betul sekali. Jadi meskipun tagline-nya adalah bisa mengakses model tanpa internet, waktu nge-running pertama kalinya itu butuh internet untuk download modelnya tadi. Nah, tapi setelah modelnya sudah berhasil di-download, untuk interaksi dengan modelnya sendiri, itu sebenarnya nggak perlu untuk nembak API atau mengakses internet manapun, gitu ya. Kalau misalnya di-running di lokal. Harusnya bisa. Kalau tabletnya kuat ya. Mau di-running di lokal di tablet kan maksudnya ya. Oh, kalau ini ya di cloud bisa. Bisa. Tuh. Oke. Ada yang sudah berhasil ngedeploy ini? Coba angkat tangan yang berhasil berapa banyak? Oke, masih sedikit. Oke ya. Ada yang masih proses deploying? Belum selesai? Oke, masih banyak. Ya, kalau gitu, sambil kita nunggu yang lain belum deploy, kita sambil lihat-lihat step selanjutnya ya. Jadi nanti kalau misalnya udah selesai deployment, teman-teman kan bakal sudah dapat nih URL seperti ini. Nah, untuk yang udah selesai bisa langsung ngeset environment variable di terminal supaya bisa lanjut ke step berikutnya. Jadi yang udah selesai, kita akan mengambil URL tadi yang di display di terminal untuk masuk ke variabel olama URL di sini. Jadi bisa di copy, kemudian bisa di paste. Oke. Nah di komen ini sebenarnya kita akan mencoba untuk nge-parsing aja sih dari service URL yang ada di terminal supaya masuk ke environment variable olama URL. Karena nanti environment variable olama URL ini yang akan kita utilisasi di IDK. Oke. Ya, oke, kita lanjut dulu kalau gitu. Nah, untuk proses selanjutnya, kita akan masuk ke deployment IDK-nya. Ya, untuk deployment IDK-nya, source code-nya itu ada di directory IDK agent. Jadi, coba dicek baik-baik, teman-teman working directory-nya itu ada di directory yang mana ya. Lalu masukkan ke change directory ke IDK agent. Nah, contohnya seperti ini ya. Ntar ini saya clear dulu. Oke, jadi di sini saya working directory-nya sudah ada di dalam IDK agent. Kemudian yang kita lakukan adalah kita perlu bikin agent file-nya dulu, agent.py. Tuh, close edit. Nah, ketika ini dia sudah keluar, file.agent.py di dalam directory IDK agent production agent. Oke. Nah, kemudian setelah itu kita copy paste isinya ke dalam sini. Lupa di save. Dan nanti ini katakan bahas sambil nunggu deployment ya. Nah, tadi agent.py-nya udah siap. Sekarang kalau misalnya teman-teman ingin mengakses agentnya itu sebagai backend service, nah sebenarnya dari IDK itu sudah ada komen untuk membuat agent tersebut itu as backend service dengan menggunakan Bahasa API, gitu ya, langsung dari command line. Nah, tapi di contoh ini kita akan melihat kalau misalnya teman-teman nih pengen bikin backend service yang custom, misalnya nih kan udah ada root default atau endpoint default yang dari IDK, pengen ditambahin dengan endpoint lain yang teman-teman punya mungkin untuk keperluan menambahin feedback atau mungkin ada business logic yang lain gitu ya. Nah, ini adalah caranya untuk melakukan hal tersebut. Jadi di sini kita bikin file baru lagi, namanya server.py. Kita akan running di sini. Oke. Lalu kita akan copy paste code yang di sini tadi ke server.py. Jadi kita sudah di state ini kita udah punya dua konfigurasi. Yang pertama production agent di agent.py dan yang kedua adalah untuk backend service mengakses agent tersebut di server.py. Nah, kemudian yang terakhir kita perlu bikin docker file supaya server.py-nya ini tadi jadi backend service. Jadi kita cloud shell edit lagi docker file di dalam situ. Oke. Lalu kita copy isi docker file-nya dari tutorial ke dalam file tersebut. Nah, jadinya sampai di state ini kita punya agent.py, kita punya server.py dan sudah punya docker file. Ya, notasi. Ya. Oke. Nah, kalau misalnya file-filenya udah selesai, kita akan coba untuk mengkonfigur environment variable yang diperlukan ya untuk IDK agent tersebut di step 9. Jadi ini make sure lagi bahwa working directory-nya ada di dalam IDK agent. Lalu kita nge-run command ini, teman-teman. Sudah dalam IDK agent. Ini saya clear dulu.
Anyone needs help?
Yes.
Questions?
Oke.
That's it. That's
Jadi komen yang barusan kita masukkan di sini itu dia sebenarnya membuat suatu .env untuk mengkonfig backend service yang barusan kita punya supaya backend service-nya tadi sudah punya informasi terhadap olama URL yang sebelumnya kita deploy untuk aktif di backend service tersebut. Oke. Dan lalu yang terakhir, ketika itu semuanya udah selesai, kita bisa deploy ADK agent-nya di sini.
Ini berarti agent-nya udah seperti olamanya yang mana dari variable yang udah disimpan tadi.
Iya, betul. Nah, di sini sambil kita nunggu ya proses deployment-nya, kita akan coba inspect dikit di dalam agent-nya tadi seperti apa. Oke. Nah, jadi ini adalah isi file dari agent.py. Di dalam isi file agent.py ini, kita ada banyak konfigurasi untuk dapetin Google Cloud Project, Google Cloud Location, gitu ya. Nah, tapi yang perlu kita note di sini adalah dia punya akses gamma model name yang sudah sebelumnya kita deploy itu seperti apa. Kemudian API base-nya pun kita juga udah set nih. Tadi kan ada komen untuk nge-setting file.env ya. Di file.env tersebut kita nge-configure olama URL-nya itu seperti ada di mana dan dimasukkan filenya ke dalam olama API base. Nah, dari sini tuh kita memberitahu bahwa ADK-nya menggunakan let LLM bisa connect ke olama di URL tersebut yang tadinya sudah kita deploy. Nah, dalam inisialisasi ADK-nya sendiri, di sini kita menggunakan agent, ya, LLM atau LLM agent di ADK, dan di modelnya kita sudah specify tuh, let LLM, dia menggunakan modelnya olama chat, ya, jadi dari spesifikasi nama modelnya di olama sendiri, kita sudah kasih prefix olama underscore chat, dan kemudian kita pinpoint API base-nya ke URL Cloud Run yang barusan kita deploy.
Please feel free to put your hand up if you have questions.
Ya. Oke. 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 Ya, Mas.
Sorry, ini metode object let LLM itu ngapain? Itu ngeload modelnya, dia tahu. Let LLM itu punya functionality sendiri.
Iya, jadi gini. Masnya kalau misalnya mau pakai menggunakan SDK Gemini, itu cara untuk ngeformat datanya kan beda kan ya. Untuk memakai olama, cara ngeformat datanya juga beda. Let's say masnya juga tertarik sama model Anthropic Cloud, format datanya juga beda, gitu. Nah, let LLM ini tuh menjembatani itu semua supaya dengan satu format standarnya let LLM itu dia bisa switching model apapun sesuai yang terdaftar di let LLM tersebut. Gitu. Jadi misalnya nih, ini sekarang kita pakai olama untuk ngedeploy Gemma kita. Misalnya nanti masnya pengen explore framework lain ya, misalnya VLLM, yang juga salah satu yang populer juga, tinggal diganti aja. Oh, prefixnya diganti VLLM sesuatu, nama modelnya Gemma, nah nanti udah langsung bisa connect ke framework tersebut, hanya cuma ngeganti satu line aja.
Tapi kan untuk small LLM doang.
Untuk semua open model. Open model dan ya bahkan pun untuk paid model seperti Gemini, Anthropic, Cloud itu juga mereka bisa connect. Kayak gitu. Oke. Ya, jadi ini deklarasi agent yang kita punya. Nah, kemudian kalau misalnya teman-teman tadi pengen nge-expose agentnya itu sebagai suatu backend service, sebagai fast API contohnya ya, dan pengen nambahin rute baru, di ADK itu sudah ada built-in modul namanya Get Fast API App. Nih, jadi partnya dari sini, google.adk.cli.fastAPI, Get Fast API App. Nanti objek yang dibalikkan oleh modul ini sudah berupa app-nya Fast API. Di sini nih. Ini udah objeknya Fast API. Nah, selepas dari sini misalnya teman-teman pengen bikin startup rutin baru atau pengen menambahkan root ya, sebagai contohnya di sini kita menambahkan root help /help. Nanti dia udah akan running sebagai backend service root sendiri di situ. Cuma kalau yang bawah yang slash itu harusnya ke redirect sih.
Kok mirip kayak Flash?
Ya?
Mirip kayak Flash.
Fast API emang mirip sih sama Flash.
Basically same thing.
fungsionality-nya sama.
Service full.
Untuk ngebikin backend service, tapi kalau dulu Fast API itu lebih ke arah ASGI, jadi asynchronous backend service. Jadi dia support, kalau misalnya di sini kan semua functionnya sinkronus ya, karena deklarasinya pakai dev. Kalau ditambahin async depannya, itu dia bisa jadi asinkronus.
Tapi ya basically
Ya, lebih buat untuk bikin HTTP backend service. Oke. Jadi kurang lebih seperti itu. Kalau misalnya teman-teman udah berhasil, ya mirip seperti tadi ya, berarti kita sudah punya 2 service deployed, yang satunya service Olama, dan yang kedua adalah service dari IDK agent-nya. Nah, kalau teman-teman pakai IDK dan meran dengan default deployment-nya dia ya, dia itu bisa punya namanya web development UI seperti ini. Gitu. Jadi ketika teman-teman buka URL deployment IDK-nya, pastikan tadi konfigurasinya udah benar, akan muncul web interface seperti ini, di mana teman-teman bisa udah ngobrol dengan agent yang di-deploy. Who am I? Who are you? Okay. So. Nah, kalau misalnya teman-teman penasaran nih, dari tadi kan kita interaksinya lewat terminal semua gitu ya. Teman-teman bisa ngecek service yang udah di-deploy, itu dari Cloud Console, masuk ke Cloud Run. Nah, nanti teman-teman bisa lihat nih, service-service yang barusan di-deploy itu ada apa aja. Yang pertama kita punya Olama Jema, lalu kita yang kedua punya ADK Agent. Gitu. Nah, setelah ngobrol, nanti teman-teman udah bisa tes bahwa aplikasi ADK teman-teman udah terkoneksi dengan Jema, dan dia sudah bisa berhasil untuk meran Jema tersebut di atas service GPU tersebut. Gitu. Jadi, ini adalah salah satu contoh bagaimana dengan sedikit komen aja, teman-teman sudah bisa punya open model yang terdeploy menggunakan GPU di serverless produknya Google Cloud, yaitu Cloud Run. Kalau misalnya teman-teman nanti pengen mengutak-atik lagi, misalnya pengen concurrency-nya lebih banyak atau concurrency-nya lebih sedikit, maksimum instance-nya jangan 1 deh, coba 2 atau 3. Nah, teman-teman bisa bebas ganti-ganti di parameter yang tadi teman-teman gunakan untuk deploy. Atau juga bisa via interface Cloud Run ini. Jadi teman-teman bisa klik di dalamnya sini untuk masuk ke detail dari service-nya. Teman-teman bisa cek matriks-matriksnya yang sedang aktif apa aja, banyak request berapa, lalu utilisasi GPU, utilisasi CPU, memori, itu semuanya ada di dashboard yang bisa ditampilkan di sini. Gitu. Nah, misal teman-teman pengen ganti environment variable ya, atau misalnya pengen modifikasi nih, saya pengen rollout-nya nggak langsung begitu deploy, langsung rollout 100%, pengen memanage traffic-nya, mungkin untuk canary deployment, atau mungkin untuk A/B testing di level service gitu ya, itu juga bisa dilakukan di halaman revisions atau edit dan deploy revisions. Nanti teman-teman bisa atur, contohnya kalau misalnya mau mengatur traffic, bisa dari manage traffic di sini. Gitu. Jadi dengan menggunakan Cloud Run, teman-teman bisa punya manageable service yang dengan mudah dikonfigurasi via UI ataupun via CI/CD platform. Oke. Tunggu, Mas. Nah, kalau di model Garden, itu semuanya sudah di-handle oleh Google Cloud. Masnya nggak perlu lagi untuk nge-handle Docker file, untuk deployment, atau mungkin nggak perlu untuk bingung-bingung lagi cari. Kalau misalnya masnya pakai Olama, masih harus cari nih, ngedeploy model Gemma dengan parameter berapa, 300 ya kalau nggak salah ya, itu GPU berapa ya yang saya kuat. Jadi misalnya masnya pengen ngedeploy GPU yang dengan menggunakan GPU yang dimiliki saat ini, masih belum tahu, misalnya model DeepSeek kuat nggak ya, atau model Quen kuat nggak ya. Nah, kalau model Garden itu semua sudah di-provide default-nya seperti itu, dan sudah siap untuk production grade, dan masnya bisa langsung utilisasi langsung. Dari situ tanpa perlu memikirkan harus eksperimen dulu GPU yang memorinya seperti apa, lalu harus mengotak-atik Docker file-nya juga. Itu semuanya udah di-manage sama model Garden.
Tapi secara pricing sama berarti?
Kalau pricing seingat saya agak berbeda. Nanti bisa dicoba dilihat di pricing detailsnya model Garden juga. Karena tiap-tiap model yang ada di model Garden itu juga ada yang harus nge-instantiate instance sendiri, ada juga yang bayarnya pay as you go. yang berbasis token. Gitu. Jadi nggak sama rata untuk semuanya.
Mas, aku nggak ngerti, Mas.
Bentar, Mas. Monggo, Mas.
Kan itu waktu deploy pasti ya. Nah itu yang ngaruh ke bank dan lain-lain. Nah, ini kan kita yang ampun buatnya punya kredit. Apa aja yang ngebuat harga dari setiap menggunakan AI itu beda. Ada yang lebih banyak, kan
Kalau concernnya lebih ke arah cost, sebenarnya variabel ketika kita bicara tentang AI agent itu banyak banget, Mas. Gitu. Kita bicara dari layar, misalnya layar infra yang paling bawah ya. Di layar infra sendiri pun di pelan masih kan bisa ngatur minimum instance berapa. Jadi ketika mengatur minimum instance berapa, misalnya nggak ada traffic, instance-nya mati. Tapi ada cost-nya. Kalau misalnya application masnya itu secara start time itu memakan waktu lebih besar, ya otomatis request yang masih masuk pada saat instance-nya 0, itu bisa gagal kan. Karena belum ready instance waktu dia speed up lagi. Bisa jadi salah satu faktor cost ya antara ready traffic dengan infra yang udah nyala dulu. Nah lalu di perspektif agentnya sendiri tergantung masnya ngedesain agentnya seperti apa. Let's say by default nih, masnya pokoknya user bisa ngechat sepanjang apapun dan semua history conversation-nya juga masuk. Nah itu berarti costnya juga akan lebih besar kan? Kayak gitu. Jadi memang grafiknya itu kurang lebih sekian. Memang belum ada varian pada itu kalau dari perspektif saya selalu harus eksperimen gitu. Jadi memang eksperimen terhadap suatu case tertentu, lalu kita atur itu case-nya apakah memang butuh konteks sepanjang itu atau mungkin malah nggak butuh konteks percakapan sama sekali. Gitu. Nah, baru dari scoping yang kita tentukan itu kita bisa running evaluasi kira-kira cost-nya berapa, lalu bahkan mungkin 10-100 evaluasi average cost-nya berapa, biasanya dilihat dari situ. Oke, mungkin satu pertanyaan lagi dulu ya, nanti kalau misalnya itu bisa tanya di luar sesi.
Aku pengen bikin konektor. Soalnya kan server kan ngefek server kan akses agent yang dia ngeload model. Cuman saya nggak ngeliat di sini ada something yang ngeload apa ya agentnya di server. Nggak konektornya.
Oke. Tadi kan punya Jama di atas Olama kan ya Mas ya? Ya, modelnya sendiri running di service terpisah di Olama. Anggap aja modelnya itu sudah jadi HTTP service sendiri, udah punya API sendiri. Lalu di bagian AI agentnya, di ADB agentnya, untuk konektor Olamanya tadi kita pakai Light LLM. Jadi agent service-nya sendiri dia nggak ngeload model apa-apa. Cuma menggunakan interface dari Light LLM, dia bisa connect ke Olama langsung udah standar. Gitu. Nah, sedangkan agentnya sendiri sudah dibungkus menjadi suatu backend service menggunakan fast API. Fast API-nya di-run menggunakan UV core di situ.
Jadi sebenarnya ini mereka individual separated Python file tapi baru di connect pakai ADK ini.
Nah, betul. Jadi ADK-nya itu jembatan untuk masnya nge-develop AI agent itu dengan jauh lebih mudah lah. Hanya dengan beberapa line aja, kalau di situ dilihat kan sebenarnya panjang instruction prompt-nya kan ya. Tapi kan sebenarnya untuk parameternya sendiri kan sudah sedikit.
Backend server nanti load put agent di agent.py gitu.
Oh, itu udah diambil sama IDK-nya semua. Oke, kalau gitu teman-teman, ya untuk yang mungkin masih punya banyak pertanyaan, nanti kita kan masih ada proses building juga kan ya. Nah itu feel free aja untuk reach out ke TA-nya, nanti kita bisa saling diskusi di situ. Karena semua yang di sini bisa bebas mau tanya ke siapa aja, feel free lah untuk reach out ke kita ya. Oke, mungkin sekian dari saya. Thank you everyone.
Thank you, Alvin. How many of you were able to successfully complete the deployment? Awesome. That's more than 70% in the room. That's amazing. So before we head straight into the build and blog part of the build and blog marathon, we also have Shruti Mantri from, am I saying your name right? Okay. For just a quick lightning talk on serverless runtimes, particularly talk about the Cloud Run aspect, everything that's latest with Cloud Run and serverless runtimes in general. and the AI integration aspect of it, because right after that, you're going to start picturing or diving deep into taking your idea to production. So this is very critical in that journey and very simple too. So over to you, Shruti.
Hello, everyone. Good morning. Yeah, so I'm Shruti, and yeah, today I'll be walking you over the UI of Cloud Run. Oh, okay. So I come from India office in Bangalore, and I am part of the serverless team itself. So it's my team who develops Cloud Run and App Engine and few other serverless services. So today I'll be walking you over what all exists in Cloud Run from the UI perspective and how it can help you in your journey when you will be developing with Cloud Run, how to go about checking the logs, checking the metrics, and so on, right? So let's get started. So when you go to console.cloud.google.com, this is your homepage. And then on the top, you can search for Cloud Run. And this is like the main page where you will come when you get into the Cloud Run. So if you have no services present, then you will have some page like create the service, and this is what will open up, right? So here also you can go ahead and create the service right by clicking on plus mark over here, deploy container. And now you can deploy Cloud Run service in a couple of fashion. You can have deploy using container image, which is the first one. Then second one is from a repository. If you already have some code in your GitHub and you want to deploy that code, this is where you can use continuously deploy from a repository, which is this option. And then the third option is if you want to write the code directly on the UI, right? There will be a small code editor which will come up if you use this third option. So let's take an example. If you come here, you can give some container image URL. This container image can be a Docker image, or it could be some image in your artifact registry. And then you can have the service name, you can have the region, and in authentication, you can allow either public access or you can go with require authentication. And the type of billing, auto scaling features, you can leave all of this default and everything will be good. So, and you can then click on create, and then this will create the service, Cloud Run service. So it will be equivalent of what happens when you deploy, right? So when this is getting created, it's a hello world image. So if you see here, everything on the top is green and it says it's completed. So you're all good to go when everything is green. You can click on the URL which comes on the top. So here I was able to deploy a Docker image and it says it's running. Right? So what happens in not so happy scenario? Looks like suppose something failed, right? That is where you can come to this observability tab. See the metrics, how many number of requests you have sent, how many are successful, what is the status, and so on. So as of now, I just clicked it once. It will take, this page takes little time, around a couple of minutes to show up any metrics on these graphs. But let's say if something fails, you can go to logs. And here you will get detailed logs about all the things that you are printing, logging in your application. And also if there are errors, it will show up over here. So you can come to this page, look out for any errors that you're getting in your application. Right, then there are SLOs and errors, which SLOs are fine because it's not completely, you're in the development phase, so you need not worry about SLOs. But for errors, you can come here and see if there are any errors that are popping up if your application is not running as expected. Then revisions. So basically, let's say you had a working code, then you wanted to implement one more feature in your code, and you make the code changes, and then you deploy again. And that is where it will create one more revision. That is, a change in your code will get deployed as a separate revision. Let's say it's not working and you want to go back to your previous code, then here you will have a lot of revisions and you can just go back to your previous code. So I can tell tell you with an example. Let's say I have this bot. So there are a lot of revisions, if you can see over here. So let's say my latest revision is not working up to the mark. So I can go back to any other previous revision by just clicking on that revision. And then you have source here. Source is actually going to show you your exact changes that are there as code. So you can come here if you want to edit. You can click on edit source. And once you have made the changes, you can click on save and redeploy. And it will save and redeploy, right? Then there are triggers. In case you want to invoke this function rather than from a URL, if you want some action like an event in pops up to trigger this Cloud Run service, then you can add triggers. If you want an addition of file into a Google Cloud Storage bucket to trigger this function, you can add a trigger, right? So for all these purposes, you can add a trigger. And then there is networking tab, and then there is security. In case you want to allow public access rather than require authentication, you can click on allow public access, and then you will be directly able to hit the URL. As of now, this requires authentication. So if I directly hit this, it might not run. It might say it requires authentication. I'm unauthorized to open. This is what it will end up saying me. It's okay. I'll proceed on. And then, so these are all services. This is everything related to service. Cloud Run also provides you with jobs and worker pools, as you can see in the left navigation menu. So these are jobs, and then there are worker pools. Let us have a quick understanding of what is jobs and what is worker pools. So just like if any one of you have worked on Spark, anyone worked on Spark, Apache Spark? Okay. Or any, so basically what jobs are is you trigger it so that it runs and it finishes off. There is no direct interaction of the person with the service. Based on some trigger, it will run and it will do its job and it will finish off like a background job, right? So for example, this is some screenshot job and you can just click on execute and it will start executing. It will do its work. Whatever tasks are there inside this, it will execute all of them and it will finish off. Now, this is very helpful when you don't want any user to interact directly with your application, but you want your job to run in the background. And in the observability, you can check all the metrics and logs associated with your jobs. Also, you can add trigger. Trigger is very similar to what is there in service, but you can also have schedule trigger, which is very popular with jobs, that on every regular interval, it will run and then it will finish off. And then you have worker pools. Worker pools are so in jobs, what happens was when you create the service, when you trigger it, it will run as a background job, right? And it will finish off. In worker pools, the workers will be running continuously throughout, very similar to a Kafka consumer. So here I had given an example of a Kafka consumer worker pool itself. So it has been continuously running and listening to events. If anyone of you have used Celery, Celery also has worker pools, very similar to this. But the whole difference between this and that is this is serverless. You don't have to manage the server. Another example of worker pools is the Kafka consumer worker pool. So here you can have auto scaling or you can have manual scaling. In this particular case, I have put manual scaling to 5. That means 5 servers are there continuously running and listening for events. So very similar functions you will have here for observability, revisions, and networking security. So in observability, you can see the metrics. So there has been some CPU utilization. The instance count has been 5 on a continuous basis. When I started this, let's say around, I think 7 days back, or in fact, even more, I started this with lesser number of services to begin with. So this is the instance count. It has always been 5. So when I started it, I had started it with 1 for some time. Then I scaled it to 5 and then it continued to remain at 5. You can also change it from manual scaling to auto scaling. and then it will change depending on the amount of traffic that the worker pool is handling. And then rest of the other things remain the same, right? And then you have configuration for each of them, and that is part of YAML, but that is a bit of advanced concept. You might not use it very regularly, but let's say if you want to change anything in the configuration perspective, you can go to YAML and edit it. This contains the name of your service, some of the annotations, some of the labelings, and so on. So yeah, I think that's all about the overview of Cloud Run. And I hope now you understand what all functionalities you can use while debugging when you're using it when you're deploying and when you're developing in Cloud Run. These are some of the go-to tools which you can use. Any questions? Okay, yeah, thank you. Thank you, everyone.
Thanks a lot, Shruti. That was concise and very helpful. So before we move on to the next step, let me just quickly share my screen and some important things that you would want to know. Are you excited for the build and blog part? Why is that yes so sad? How many of you have already come with the idea, the intention for what you want to build? Okay, okay. Okay, you still have time here to think about what you want to build before you actually start building. 1 second, allow me a moment to share. Okay, there we go. Okay. So you already have the instructions sent over in email. You already have the guideline reference architecture with all the technology components and every single service or product that will help you get your ideas through production, or things that will tick off the assessment criteria. So both were already sent to you. This deck was also sent to you. But however, I'm going to walk you through the assessment criteria for the ideas of the projects that will be shortlisted tomorrow, which we'll be building starting today in a bit. So first thing is Cloud Run usage. Of course, sticking to the theme, Cloud Run and data and AI. So Cloud Run for sure. That will be counted as mandatory implementation. GCP database usage in some form. You must have listened to all the data cloud aspects and all the databases that are available in Google Cloud Platform in Ankur's keynote. So yes, we'd be looking for your choice of data cloud service. As part of it, you can also optionally use cloud storage, Google Cloud Storage, if you feel that getting a database integrated and completing that over the scope of 1.5 days or maybe 1 day left, right? So that's probably, if you find integrating to a database is probably a little time consuming for you, you can also choose to use Google Cloud Storage, or both if it matches your use case and your requirement. So that counts for 2 points. And then you have Google's AI usage. So I encourage you all to try out Gemini 3.0 Pro preview. That's in public preview right now. You'll be thrilled. It's just that for your actual deployment and testing purposes, use 2.5 Flash, but also try out how cool Gemini 3.0 Pro preview is. If your use case is something that is highly demanding in terms of number of requests that you need to make to test or to implement it, use 2.5 Flash, because that doesn't, that's really, it's Flash Lite for a reason. As opposed to Pro, it's a thinking model as well, in addition to all the great things that you get, the deep thinking, the PhD level reasoning that you get. If your use case doesn't demand that level of expertise in answering questions, then stick to 2.5 Flash Lite. Also, the responses will be really quick, right? Because of the Flash Lite compatible thing. Next is functional demo. Everything that you build and what you submit tomorrow has to be functional. The demo has to be functional in the deployed app link that you'll be sharing. If it's a mobile app as opposed to a web app, and your final application is not deployed on Cloud Run itself, I would encourage you to at least have one backend component implemented in either Cloud Run functions or Cloud Run. I hope you all know the distinction, right? Cloud Run functions more targeted towards a single point in scope or requirement in scope kind of implementation, where you just have a one-page application quickly deployed, something that's repetitive, something that's lesser in scope. limited in scope as opposed to your entire application being deployed or a front end or a back end completely deployed on Cloud Run, right? A Cloud Run function supports activities like, let's say you have a backend update periodically or something that triggers only when a table row insert happens or something like that. So Cloud Run functions will help you set up that really quickly. So at least one of your functionalities need to be implemented on Cloud Run. So that needs to come off very clearly in the blog. And what the blog needs to cover, we'll talk about that later in tomorrow's segment where we have the instructions for blog. But yes, the next one, as we directionally enter the blog excellence, your blog has to be comprehensive, of course, but it also has to be technical, because your audience are going to be technologists, technical experts, and developers who'd like to gain value from reading for the time that they spend reading your blog, right? So all those instructions for your blog will be given tomorrow, but just know that that carries 5 points. And finally, impact of the use case that you choose to build in any specific industry or technology or tech stack or programming language of your choice, that carries 5 points as well. So as you know, we are not limiting you by industry or use case for this one reason, that we want you to be innovative and we don't want everyone building the same solution. But at the same time, be mindful of the time also, because we have limited time for you to build and ship. So keep it tangible, keep the scope limited. Just don't go about building so many different features and fine tuning and everything, but have it factored in your blog so we know where you're heading and where your head's at. However, just make sure that you also keep your deliverable tangible so that you're able to complete. Yeah. So this is the assessment criteria list. Next up is your Gaia Mentor tool. So I'm going to send you an email right after this quick the quick instructions that I'm handling right now. Right after this, you'll be receiving an email from the same email that you've been receiving from RSVP in the past few days. So that email will contain the link to the app. It will also give you the username, and this is important. So I request all your attention, please, because if you miss this information, folks out there who are chit-chatting, please, can I get your attention? Like, really, that's it. Thank you. We need your attention, because if you miss this, you probably will have a lot of questions tomorrow. I don't understand. Hello, I'm talking to you. Yeah. Can you give me your attention for like 5 more minutes? Yes, because this is important. If you don't listen today, you'll probably have a lot of questions over the course of 2 days, and then it'll impact your submission and your chance of being shortlisted for the demo. So I want you to be really attentive here. So you would have seen the email and the instructions that you received repeatedly talk about a tool called Gaia Mentor. So this tool is created to facilitate your submission, the project management phase itself. But in addition to that, it is also an intelligent tool that is able to understand the context of your idea and your project, depending on what you enter, right? The information that you provide, it will summarize it, it will understand it. It will also ask you questions that drive you to completion when you hit that phase. So I'm going to go give you a quick demo of what the tool really, a quick video demo of what the tool does, and then I'll show you live as well. But then you will receive the link to the app and the credentials right after this instruction session. Yeah, so please pay attention here.
Let's sign in as the hackathon participant. Here, you have so many features to help track and monitor your project and progress. You can create your project by entering the details, design, use cases, uploading artifacts. Or you can save it and come back to edit your added project. Every progress you make can be recorded here. You can iteratively get feedback from the hackathon mentor or the owner. Also, you can create your own action items or use the AI-assisted action item generation feature to generate the checklist for your project details. You can pick and choose and save your progress. You can configure additional team members from the event list of users per your event's rules. Next, you can use the always available virtual AI Gaia Mentor for your project updates, questions, status details. You can have a live conversation, share screen showcase your demo, or share architecture diagram and more. You can answer questions from Gaia to confirm your progress. You have the option of submitting your conversation summary at some point to your mentor. This is mandatory for the auto evaluator to update the status of your project whenever you are ready to submit. Finally, when you're ready to submit your project for the event, share the deliverable details, check off the Gaia demo confirmation and click submit. You will be safely logged out from the project.
All right, so that is the video demo. And like you noticed in that particular demo, you'd have seen that you're required to have a mandatory live conversation with Gaia. We'll come to that in a bit, but before that, the team configuration. So because some of you have ideas and some of you are like, I'm still thinking what to do, you're allowed to have a maximum of 2 members in a team. So you minimum of 1, maximum of 2, not more than that. Because if you have more than that, you will not be recognized in the tool, and we'll not be able to keep track of how many team members are there. And it's also to empower you to build your own thing, and rather than having people in a group and not getting your hands on in a real world application. So we want to also limit the number of folks in the team on purpose by design. So that's why we're doing this. But a maximum of 2 in case you want to split the burden and get it completed really quickly, because we still have the scope of innovating in the industry and the use case that you want to innovate in, right? So that's the main criteria. You can have a minimum of 1 and a maximum of 2. 1-member teams are encouraged too, because we want each one of you to go out and build something that will matter to you. But because of time crunch and other things, we also allow a maximum of 2 members in a team. Yeah, not more than that. Now I'm going to show you one more thing. You will all receive the tools link in email right after this session. However, I'm just going to show you one important thing, which was already there in the demo, in the Gaia Mentor demo. So once you sign in with the credentials that will be in the email that you'll receive shortly, feel free to enter your team member. This is mandatory if you are a 2-member team, right? Otherwise, your team member will not be included. We will not know that you're a 2-member team. Live session is mandatory, like I said. You can choose to have the conversation beforehand. Once you enter the artifacts right here in the artifacts tab, don't be surprised if once you enter the artifact, if it summarizes and makes your title or description concise. Not the title, but the description and high level design, because it is designed to summarize it. But you feel free to add all the key points that you need, because it will be objective in its summary. It won't be fluff. It will be objective in its summary. So all your key details that you enter will be captured. And you can upload up to 5 artifacts. If you upload more, the oldest one will be replaced. It's all there in the instructions right here. So you'll be able to see that. But please note, your artifacts can be as detailed as your detailed design doc, or you can add everything that you want to cover in a doc, which you're not able to probably cover in high level design or use case, and upload it as a PDF as well. Yeah, please be aware of that. You can upload that in the artifacts. If in case you feel that the summary is leaving out some important information like architecture diagram and other things. So the architecture diagram generation tool was also sent to you in email. It was there in the deck in one of the slides. Please use the Genash diagram generator. It was also developed by one of our team, not our team, but yeah, extended team members, a Googler. So it'll be really helpful, and tell us what you think about it later on. It'll be really helpful for you to translate your thought into an architecture diagram, so that if you don't feel like talking about or typing a lot, that diagram will be a starting point for you to use AI to generate the context around it or the design around it. Yeah, so use that. And that diagram can also be uploaded as one of the artifacts right here in the upload artifacts section. So sample data set or artifacts description. So we're not forcing you to upload your data sets, but in case you feel like you want to share the test data that you have, not your actual production or organization's data, please don't upload any of that, even though we are not going to use your uploaded information for anything else apart from just evaluating your context. However, we want you to be careful with your organizational data. So use test data or something like that if you're uploading. Even otherwise, it's not mandatory to upload your data set here. This is just for you to enrich the data that Gaia understands about your project. That's why the sample data set upload is a step. It's not mandatory, but it's required for you to say what artifacts you're uploading. And if it contains data sets, great, talk about it. Okay. Moving on, the live session. So based on all the initial artifacts that you provide and the information that you provide in the design and use case and other things, talk about in the use case section in the artifacts, the first tab, talk about what impact you're creating to the industry and the use case that you're thinking about building, right? What is the impact, so that the tool understands, so that your use case, your application stands out, right? So in the live session, once you choose the project that you're building, you will have to give access and everything. Right now I'm sharing, it's another Meet session is open, so it's not loading, but you'll be able to get this working up and running. If you've already joined the Google Meet and your video is being shared, or some mic is being shared or something like that, make sure to turn off all the other applications that use it. Only then Gaia's live session will be able to access your camera and mic. Yeah. And this particular session will be pre-loaded with the context that you enter. So when you load your project, it'll automatically understand the basics of your project depending on the information that you provide in the artifacts tab. And it'll start the conversation with you, or you can start the conversation. You can start talking with a video, or you can click start talking. There's an attention instruction right here. Read that. It will tell you the controls that you need to use for sharing your screen to show the demo once you're ready. It doesn't mean you have to keep using this Gaia Mentor like throughout the project, but take time. Like once you make some project or a feature, go back to Mentor, talk about the feature and show a demo. Or you can wait until the end to show the entire demo of your use case. But don't have like a 2 or 3 minute conversation and try to submit the conversation summary. Try it, or try to get response. It will understand, but it won't be synchronous response. It'll be async. So you will not get an immediate response like, okay, I got your demo, but this is what you should be doing. It would instead say, I got what you're saying, but keep going. I don't want to respond right now. The reason is your context was too long, right? In this particular thing. It was limited to for a reason. So keep your conversations short, like have 25-second conversations or 20-second conversations, but multiple of them, so that you can have a coherent, continuous conversation with Gaia. But only when you're ready to submit your conversation summary each time. Once you have a conversation, it goes off. It's volatile. It doesn't stay for you to come back and submit. If you want to submit your current conversation summary, click submit conversation summary. If you don't submit, none of your conversations will be recorded. That's by design too, because we don't want all your questions to be recorded. We want only the context that you want to submit to the tool, to the mentors, to the evaluation process to be submitted. So that's why submit conversation summary is enabled only when you need it to be submitted. Yeah, but don't lose the context, because if you just have a conversation and forget about submitting and move to final submission and go back, it may not have all the context saved, but it will have the context that you have submitted right here. So make sure that you do that. And the conversation history right here will only show your active conversations. It won't show your previously submitted conversations. That is also by design. We don't want that to be like too long. It is just for you to know what is being submitted. All right, in the current conversation. So is this mandatory? Yes, this is mandatory for you to be able to do the final submission. Why? Because nowadays vibe coding is in trend. So I'm sure you all will be using it. Use Firebase Studio. We encourage you to use it as much as you can. However, you should also know the foundations. If you just copy paste code from somewhere, or you just use an application that was built and don't know why you're doing what you're doing, and it's just a prototype, it's not really functional, but just like pretty screens, it's not accepted, right? Because you're competing, we want you to have the depth of both the technology that you're using, at the same time the use case and the problem that you're solving. So that's why this conversation is mandatory for Gaia to be convinced with the information or the knowledge that you have about the project that you're building. So answer Gaia's questions so that your idea is empowered to be shortlisted in the top 10, yeah, to be considered complete. All right, moving on to final submission. Choose the final project submission, and blog link is mandatory. You won't be doing this final submission today, by the way. You will have time tomorrow afternoon between 12:30 and 1:30 p.m. to do the final submission. If you complete everything today, feel free to do it. I'm not stopping you, but if you're going with the flow, we will address it, because we'll address it as a group. We'll answer questions as a group. That's why the stipulated time for each one. So blog link is mandatory. It has to be in Medium. It has to be published in your blog profiles. We'll then later on add your usernames as authors in the Code Vipassana publication channel. I'll talk about Code Vipassana tomorrow. But yes, it will be there, and a lot, like at least 40,000 developers will have access to your blogs, like will be communicated to them, so they can go through your blogs, and you'll have them access it, eyeball it, and read it if they're intrigued. So make sure to adhere to the template and the GitHub repository. Now, again, if you're particularly confidential about your code, or you want it to be private, because you're wanting to write an algorithm or some kind of startup that you want to venture out. You don't want to share all of your code. That's totally fine. But a GitHub repository is mandatory with the basic project structure that is relevant to the context of your project. So don't build a what app. Let's say you're building, your context is set up for an industry like a petrol, oil and gas industry, and your GitHub repository is set up for a cooking show or something like that. It will figure out that it's all fluff. It doesn't match. So it will probably not allow you to submit. However, your GitHub repository, at least at a high level, should have the project structure. Just the bare minimum folders should be created. But one thing that's mandatory in your GitHub repository is your readme.md file. The readme.md file can be an exact copy of your blog, the detailed technical blog that you're writing, or you can set up instructions in your README that will help the readers of your GitHub repository, or the cloner, if you're sharing the code, the cloners of your GitHub repository, to get an idea of how to replicate your project. But it's not mandatory for you to share all the source code, but the readme.md is mandatory with a description of the project and how to do what you did. All right. Moving on, live application link. This is the Cloud Run deployed app link, which is mandatory. If your app is not deployed on Cloud Run, it is still okay, but at least one component of your implementation should be on Cloud Run or Cloud Run functions. Yeah. Firebase deployment, behind the scenes, it is Cloud Run, so that is accepted also. What other deployment modes do we use? AI Studio deployment, Firebase Studio deployment. All these things behind the scenes, you use Cloud Run, so you're sorted. But for the folks who want to use purely Cloud Run, that is also encouraged. So use that in the live application link. But remember, your live access application link must be accessible. If you have a mobile app and you're not able to give the live application link, just at least build a plain HTML page or something that's static that has the context of what you're submitting as your idea description. Just like a user authentication page, but the title should be like, if something is in the a cooking app or something, your landing page should represent that, at least the bare minimum, because the automated validation tool will go into your page, the landing page, and look at the components to see whether it's matching or not, right? It won't go through all the steps of your tool. It's not like a computer use tool. We didn't want to go overboard with that because we'll still do manual validation, but yeah. So create a static HTML page if your mobile app is not an actual shareable link, right? And finally, the demo video link, keep it under 3 minutes. So 2 minutes to 3 minutes is a sweet spot. So this demo video link can be a YouTube video that's unlisted if you wish, or you can also make it public. It doesn't have to be unlisted. I just said unlisted because some of you might not be comfortable to share just a muted demo video or a video to be public. So it's up to you. It can be public or public and unlisted, so that only people with the link can access. However, it has to be accessible. It can also be a Google Drive link. It can be any link which is accessible as a video and should be public, or anyone with a link needs to be able to access it. So please be mindful of that. Closing notes, don't say completely done, I'm so happy. Write something that's more meaningful to you, your experience, or something that you want to call out. Yeah. So some folks had a problem submitting their blog link. So if you feel that you're not able to submit your blog link, you can alternatively choose to do a Google Docs or something like that. Copy paste your entire Medium blog content into the Google Docs and make it public, and put the link here in the blog link if you're unable to submit, and then use this closing notes to share the actual blog link, or whatever link is not working, you can actually use that here. And finally, you have to confirm manually that you're satisfied with the conversation that you've had with Gaia, which internally means Gaia is satisfied with whatever conversation you've had and is ready for you to submit your project. And then click your final submission, which is save and submit final project. This is the real challenge. You won't be able to successfully get through this phase if your project is meaningfully connected in all the deliverables that you've submitted here. So a lot of people complain that, oh, they're not able to submit. It's because one of the criteria is not met, not like surface level criteria, but deep down, either you're talking about something else and your project represents something else, or somewhere something is mismatched. And this is the real challenge. If you're able to get through all that and submit your final project, all of you are winners who are done with the final submission. So that's how it's been. A lot of people enjoyed the conversation, enjoyed the submission process, because they felt like this is a first level validation in itself. So everyone who's able to do the final submission means your project is validated already, right? And then we'll do the manual validation, which it automatically ranks while you submit it. You won't see the ranking, but we will see, and we'll be able to go through manually and pick the top 10. We won't just go with the tools selection. We will also manually validate that, and the top 10 will then get to demo on the stage, and then we'll pick the top 3. Exceptions can be made if there are ideas that are really compelling that we want to give out more rewards. So remember, in Bangalore, we gave out 6 rewards. In Hyderabad, we did 5. And online mode, we gave out 6 again. So yeah, you will probably continue the trend in Jakarta as well. All right. So going back to the deck really quickly. So these are the resources. You have access to this deck. You all have access to this deck. So you've completed the code lab, so you don't have to go back to that blog template. You can look at it after you've built your project completely. Reference architecture, you can take it as a reference. You don't have to implement all the components you see in the reference architecture. Don't go overboard, but at the same time, you have to have at least one component per pillar or per area, product area in that reference architecture. Use the architecture diagram generation tool, like I said, for help with the generation of the architecture diagram at a high level. You already activated the credits, so the $10 credits should be useful. But for folks who need more credits, there is also one more credits link, which I'll be sharing with you right now. Okay, it's called... I'll also put this in the same deck. So when you go back, you have access to this. When you go back to the deck. Yeah. So as you can see right here, this is the first link you all have already activated. Oopsie, sorry. I'm trying to zoom it, but yeah, that's all the zoom I can do right now. Here, the second last line right here, it's BMBM, which stands for Build and Blog Marathon, -2025, -BLR-1. We just created it for Bangalore as an extra link. Since it has remaining credits, you all can continue to use it. So BLR-1, -2 also works in case that's fully redeemed. So this is extra credits. You don't mind. I mean, you don't have to take picture or anything. You have it in the slide deck that was shared with you. So go back to the slides and you can copy from there. Make sure you're logging into your personal Gmail account, the same thing that you use for your hands-on. All right. So with that, anything else? Yeah, that's about it. You can get started in the next 15 to 20 minutes. Brainstorm your ideas. All right. So come up with your ideas. And if you're forming teams of 2, please feel free to do that in the next 20-25 minutes. Figure all that out. Then we'll break for lunch, come back and start building. Or you can already start building if you're all set. Feel free to use Gemini CLI to unblock you. It's very simple. All your Cloud Shell terminals should by default be loaded or installed with Gemini CLI. If not, just put your hand up. We'll walk around you. We'll come to you and we'll help you install Gemini CLI. It's just right there. Just go to Google search and do a Gemini CLI installation or Gemini CLI basic usage. You'll find the one command installation link, one line basic command for installing Gemini CLI, and then the Gemini command that opens up the conversation with Gemini. Yeah, it's very simple to unblock yourself while you're coding. I'll encourage you to use all the vibe coding apps and still exercise your deep technical knowledge in bringing your ideas to fruition. Make sense? Questions? Yes. Yeah, GPU is not mandatory. GPU hands-on part is all done. So don't worry about using the GPU that you used in the hands-on part again for your build and blog. You have a point, Molly? If you deploy in Firebase Studio directly to Firebase, behind the scenes it's using Cloud Run, so I guess it's okay. But our whole point is for you to learn how to use Cloud Run with using the gcloud command, because not all... Are you a working professional? Okay, so no, the reason I'm asking that is in your organization, or if you're interning somewhere or soon to be interning somewhere, you'll probably not use Firebase Editor or Firebase Studio to build your applications, right? They'll be already set in the platform. So you'll need to know how to use the G-Cloud commands to directly do a one command shipping to cloud, or to use the console to deploy. So that's the whole point of using Cloud Run. But for convenience and the purpose of time saving, I'm okay with deploying through Firebase Studio as well. All right. So just a final note, I haven't introduced myself formally. I'm Abhirami Sukumaran. I'm also part of Ankur's team, Alvin, and we're all in the same team, Molly. And I'm a staff developer advocate, and I predominantly focus on cloud databases and AI journey, data to AI journey, and bringing together my area of focus, or the area of research that I predominantly work on, is vector search and how to use advanced vector search techniques using scan index and other index mechanisms to bring the context that you have to your e-commerce and other industrial applications in real world. So that's a little bit about me, and let's get building. I'm really looking forward to see what you're going to build. Just one last poll. How many of you are from, how many of you are working professionals, like currently working in organizations? Okay. Interns are fine too. Just put your hand up, even if you're interns. Okay. And students? Why are you shy to put your hand up? You can be a student. You're soon to be professional, so yeah, feel free. All right. Cool. That's really interesting. I'm curious to see what you're going to build. So build something that makes the most sense to you, your industry, or your organization, or your startup venture, or anything of that sort. Thank you. I'm around, and we're all around.